José Luis Cortés, el director de Educación Continua, nos va a dar la bienvenida y dirigir unas palabras. José Luis.
Bueno, muy buenas tardes tengan todos ustedes. Yo celebro mucho estar aquí esta tarde como director de Educación Continua, porque este diplomado de Diseño y Construcción Sostenible, que es la sexta vez que se imparte, pues ha sido todo un éxito gracias a la participación del Departamento de Arquitectura y bueno, a todos los maestros que han estado involucrados en este diplomado. En esta ocasión, bueno, tenemos aquí a Raúl, a Valerí y a Delfín. Muchas gracias y felicidades. Pero algo que es muy importante es la trascendencia de la huella que está dejando este diplomado en la formación de profesionales que realmente, pues, si no son ahorita, pero van a ser punta de lanza. Yo creo que muchos de ustedes ya lo son punta de lanza en la transformación, pues, de toda la filosofía de cómo construir de manera sustentable. Es realmente, pues, un privilegio para la Universidad Iberoamericana el tener, pues, haber tenido esta iniciativa desde hace varios años de apostarle a enarbolar la bandera de la sustentabilidad, y creo que a lo largo de estos años hemos aprendido mucho todos y hemos tenido, pues, el honor de contar con grandes exponentes que han venido de diferentes partes del mundo y gente muy comprometida en el tema del diseño y la construcción en materia de sustentabilidad. Yo quiero felicitarlos a todos por haber llegado a la meta, por haber terminado este diplomado. Sé que hoy es la última sesión y que mañana inicia también otro curso de Biomimicry, que en español, bueno, es biomímesis, que siempre es difícil, biomímesis, es decir, no todo el mundo lo puede pronunciar de manera adecuada, pero en inglés es más fácil, y que nos va, para todos los que vayan a participar en él, pues nos va a abrir, que dijéramos, la mente en todo lo que la naturaleza significa en el impulso de la investigación en materia de construcción y su relación, sobre todo, con el futuro de nuevos materiales de construcción que de alguna manera se están innovando todas las formas de hacer arquitectura y que nos van a permitir, pues, tener una, pues, presencia en la sociedad mucho más acertada. Yo estoy convencido que la forma como hemos venido operando en el pasado, pues, ha sido en base a las prisas. Las ciudades han crecido de manera muy rápida, hemos tenido tasas de migración del campo a la ciudad muy fuertes, y bueno, el ejemplo más vivo es la Ciudad de México, ¿verdad?, que cada 10 años ha tenido que aumentar en el mismo número de sus habitantes desde 1960 hasta la fecha, pasando desde 4 hasta más de 20 millones. Y naturalmente, en ese proceso de urbanización, pues hemos cometido muchos errores, ha rebasado la capacidad del Estado, de la sociedad civil, y creo que todos ustedes están muy conscientes de esos errores, pero lo importante es prepararnos para esta nueva era, o sea, este nuevo siglo, en el cual yo estoy seguro que se van a reconvertir las ciudades. ¿Por qué? Porque las tasas de crecimiento están bajando, porque los procesos migratorios también están bajando, es decir, ya gran parte de la población del país está urbanizada, 75 a 80%, y no llegaremos mucho más allá, de manera que ya terminaron de llegar la mayoría de los que tenían que llegar, y tenemos que ahora ver cuáles son los errores que cometimos y cómo no seguirlos cometiendo para poder construir mejores ciudades. Y a ustedes les va a tocar esa tarea de esa reconversión, y para poder lograr una reconversión adecuada, pues tenemos que evaluar de lo que estamos haciendo cada día, porque muchas de las acciones que hacemos, desgraciadamente, siguen abriendo las heridas dentro de las ciudades, que después va a costar mucho que cicatricen. Y por eso es muy importante pues, la formación de profesionales en este campo. No es únicamente el visualizar qué es lo que debemos hacer a futuro, en este siglo, en las siguientes décadas, sino desde hoy saber qué es lo que no tenemos que hacer, porque serán ustedes mismos o sus hijos los que van a tener que corregir esos errores. Yo creo que bastantes errores acumulados tenemos como para poderlos corregir, y si le seguimos aumentando más por falta de un conocimiento adecuado de lo que debe ser la arquitectura y cómo hacer una mejor ciudad, pues eso sería terrible. En ese sentido, mucha gente piensa, qué bueno que están ustedes formando gente para el futuro. Le digo, no estamos formando gente para el futuro, estamos formando gente para el presente, porque es muy importante la decisión que están tomando los gobiernos actuales, que muchas veces siguen estando, desgraciadamente, con acciones equivocadas, y que sabemos que no van a ayudar a un mundo más sustentable. Entonces, en ese sentido, pues ustedes forman parte de ese grupo de gente que va a transformar México, y pues yo les deseo mucho éxito en su labor profesional y en su labor personal, y para decirles que para la Dirección de Educación Continua, este tipo de diplomados es uno de los más emblemáticos, y que sería muy bueno que en base a la experiencia que ustedes tienen a lo largo de este diplomado, pudieran ayudarnos aconsejándonos de cuáles son las vertientes que ustedes ven en las que tenemos que participar en el futuro en la formación de los profesionales. Sus consejos, sus recomendaciones, su evaluación de lo bueno y de lo malo que ustedes ven en este diplomado nos sería muy útil, pero sobre todo saber qué es lo que necesitan los profesionales hoy en día, cuáles son los temas que ustedes consideran que son de vanguardia, que las universidades los deben de abordar de manera muy de frente, y cuáles son aquellos temas que son de innovación. Yo creo que estamos sufriendo, ¿verdad?, es decir, un gran desconcierto que existe en la sociedad de qué materiales utilizar. Es difícil para la sociedad en general y para muchos profesionales inclusive saber cuál es la huella ecológica de cada material y saber de cómo debemos de construir nuestro futuro. Y yo creo que se está haciendo toda una innovación en la industria que desgraciadamente por el abismo que hay a veces entre la industria y la academia, pues no se conocen muchas de las innovaciones y llegan tardíamente, pero la única manera como podemos cambiar es teniendo un conocimiento pleno de todo lo que se está innovando en el mundo y cómo transformarlo y adaptarlo a nuevos materiales de construcción, a nuevas tecnologías que nos permitan pues el trabajar de inmediato con ellos. Hoy platicaba yo con las gentes que llegaron de diferentes partes del mundo a evaluar el concurso de la Fundación Holcim, que seguramente algunos de ustedes participaron en ese concurso, y la discusión era alrededor de ello, de que les gustaría pues que hubiera más propuestas realmente innovadoras, en el sentido de que fueran más agresivas para transformar la forma en cómo estamos construyendo y cómo estamos diseñando. También es cierto que estaban muy contentos porque México fue el país que más proyectos presentó de América Latina, lo cual pues mucho se debe a ustedes, seguramente, a lo que han transmitido a muchos de la necesidad de participar en este tipo de concursos con nuevas ideas. De manera que, por lo que a mí respecta, pues no me queda más que felicitarlos mucho, decirles que las puertas están abiertas en la Ibero para que sigan siendo parte de esta comunidad universitaria que está interesada en transformar todos los procesos educativos y sobre todo orientarlos en este sentido del diseño y la construcción sostenible, pero el decirles que ese es el inicio de una larga carrera, o sea, todo lo que aquí aprendieron, pues es una pequeña semilla que estoy seguro que va a ir germinando y va a traer muy buenos frutos. De manera que muchas gracias por haber escogido a la Ibero para hacer este diplomado. I will now speak in English. Sorry that I talk in Spanish, but I was telling them how important has been this certificate program on design and construction in a sustainable way. And myself as director of the continuing education program, well, is one of our most emblematic programs, and thanks for all the different people that has been participating with lectures and different ways of orientating us in this program, is that I believe is a great success. So, but I want to express Megan Schuknecht, that is coming from the Biomimicry Institute, our great pleasure that you are here with us, and I am sure your lecture will be very, very important for everybody, and for the beginning of the course that you are going to have all this week in Veracruz. I am sure that will be a very, very important week with a lot of water perhaps. You have to be very well protected of the rain, but that is a good challenge, I think, to see nature as it is. And I am very proud that Professor Tom McCary is here with us as well. So thank you very much. It's an honor to have both of you here, and will enrich the knowledge of this certificate program. Thank you. Pues muchas felicidades a todos, muchas gracias, con permiso.
Bueno, pues hoy tenemos un programa muy completo, muy interesante. Vamos a tener básicamente dos bloques, uno en el que Megan nos dará una introducción al tema de la biomimesis, y después tendremos otro bloque donde estaremos Valerie, Delfín y yo hablando un poco de lo que ha pasado en México, y Tom McKeag, quien es profesor de la Universidad de Arte y Diseño de California, en San Francisco, y también de la Universidad de Berkeley, y donde nos compartirá sus experiencias en torno a la aplicación y en la enseñanza de la biomimesis. Y Megan, bueno, pues bióloga de la Universidad de Grinnell, con un compromiso muy profundo en el trabajo interdisciplinario con la ecología y la salud ambiental y los problemas de justicia social. Vivió en su juventud en los bosques y arroyos del este de Wisconsin, y después sirvió en los cuerpos de paz de Paraguay, donde trabajó con colonias de abejas. Recientemente trabaja en el Biomimicry Institute, después de haber transitado en otra área del grupo de Biomimicry en Montana, y pues tiene ya varios años enseñando, practicando, trabajando con el tema de la biomimesis, y nos trae hoy pues lo último que ha estado surgiendo en torno a la biomimesis y pues bienvenida Megan nuevamente. Es el tercer año que viene Megan a México al taller. Ya este es el quinto taller de Biomimicry que damos en México y el sexto año que tenemos, el sexto diplomado en diseño y construcción sostenible, lo cual hace pues una realidad más allá que consolidada, ¿no? Y comprometida. Y pues todo también pues impulsado por José Luis, que fue el que inició este movimiento dentro de la Escuela de Arquitectura y ahora pues lo hemos continuado todos los demás. Así es de que pues bienvenidos todos y Megan.
Bienvenidos a todos y felicidades a todos los alumnos del curso diplomado. ¿Cuántos son? La mitad, la mayoría. I also want to thank Jose Luis, I think he just left, and Raul and everyone else who was at the table, including Tom. They've really done a lot to advance biomimicry, both here in Mexico, and you'll hear more about that tonight, as well as in the United States. So they play very important roles in the work that we do. So thank you to all of them. ¿Cuántos aquí conocen algo sobre el tema de biomimesis o biomimicry? A few of you. ¿Y cuántos van a participar en el taller? Okay. So in the first part of my presentation tonight, I'm going to give you an introduction to biomimicry and what it is, and then after our break, in the second part of my presentation, I'm also going to tell you a little bit more about the work that we do in particular at the Biomimicry Institute with biomimicry education. We're based in Missoula, Montana, Montana's in the northwest corner of the United States. We have a large border with Canada, so in the far north along the Rocky Mountains, that's sort of our home turf. So as it says here, biomimicry is the practice of adapting nature's best ideas to the invention of healthier, more sustainable technologies for people. But it's much more than just a sustainable design practice. It's also an essential lens in viewing a path to a truly sustainable future. A sustainable future where all of our human designs, technologies, processes, and systems are well adapted to the ecosystems they reside in. It's also a very inspiring new discipline. If you look at these termite mounds on the left, they require zero external energy to keep their nests, which are under the ground, within 1 degree Celsius at all times. Even though the temperature in the places where these termite mounds are found might fluctuate from 45 degrees Celsius at the hottest time of the day down to almost 0 at night. So huge temperature fluctuations during the day, and yet they require zero external energy to maintain a relatively steady temperature. In our cities, on the other hand, 20% of the energy we use goes towards regulating temperature in our buildings. 20% of all of the energy we use, and yet these termites with their tiny little brains and lack of centralized control require 0. Imagine if we could start applying that to our designs. Leafcutter ants, they never get stuck in traffic. When's the last time you saw any ants here caught up in a traffic jam? When's the last time you yourself were in a traffic jam? Anybody tonight? A couple of you maybe. So Mexico City, in a study that was done in 2010, Mexico City and Beijing, China, rank right up there with having the worst traffic congestion in the world. Worse than cities like Johannesburg, Moscow, New Delhi. This particular graphic on the right is actually a graphic from the Netherlands, where people spend more than 70 million hours a year stuck in traffic. What can we learn from leafcutter ants? This shark on the left, all of its building materials used to create that shark's structure, its body, its skin, its eyes, everything, 2 polymers involved in building that shark. We use over 350 polymers in all of our building materials, our products, all of the stuff that we manufacture, over 350 polymers. Most of those not biodegradable, most of those are synthetic, many of them derived from petrochemicals. This is Janine Benyus. She wrote a book called Biomimicry, Innovation Inspired by Nature, that was published originally back in 1997. It was just translated into French. Unfortunately, it hasn't been translated into Spanish yet. But she sort of sparked a whole new movement and interest in learning from nature. The core idea is that nature, imaginative by necessity, has already solved many of the problems we are grappling with. Animals, plants, and microbes are the consummate engineers. They have found what works, what is appropriate, and most important, what lasts here on Earth. So life has been around for 3.8 billion years. That's a lot of research and development time. They've had a lot of time to test out what works, and what doesn't work becomes a fossil. It dies out. So there's a lot to learn from their wealth of experience. The conscious emulation of life's genius is a survival strategy for the human race, a path to a sustainable future. The more our world functions like the natural world, the more likely we are to endure on this home that is ours, but not ours alone. And that's a really important point that we try to remind everybody of. We share this planet with 30 million other species, and all of them have a right to exist and to thrive just as we do on this planet. So what can we do to start helping them out? The idea of learning from nature isn't new. Lots of people throughout history have observed nature and applied what they've learned to human designs. Leonardo da Vinci was pretty famous for his observations. And many ubiquitous technologies that we see today have actually been inspired by observing nature. Of course, the airplane, lots of communication technology, and Velcro. And you see on the right there, Velcro was actually inspired by a physicist who observed burrs sticking to his dog's fur and wondered how it worked, looked at it under a microscope, saw that it was a series of hooks and loops, many hooks and loops that were relatively easy to attach and detach, and Velcro was born. So looking to nature for ideas isn't new, but what's different about biomimicry is that we're now looking to nature with conscious intent. So biomimicry is not just about simply copying. So in this case, Albert Einstein, he sort of looks like his facial expressions are copying those of the owl, but that's not biomimicry, just sort of simple copying or simple copying of form. If you're just copying form without function, that's biomorphism. But rather it's looking to the biological world with the intent of taking the very best ideas and then emulating them in order to solve human problems. So in order to illustrate this in a little more depth, I'm going to share some case studies with you, and a few of you might be familiar with some of these already. This one, in some ways, is very simple, but I also think it's very elegant. I really like this case study, so I almost always talk about it. In Japan, they have very high-speed trains. They may travel up to 400 kilometers an hour, but it's also a very densely populated country, a very mountainous country, and they have a lot of tunnels. And so when what was originally called the bullet train would pass through these tunnels, it would go from one density of medium to another density of medium. And it would make a sonic boom because it would generate a pressure wave in front of its nose as it was going through the tunnel. As that pressure wave came out the other end of the tunnel, a very loud noise would occur. So an engineer, E.G. Nakatsu, who was also an amateur birder, started thinking about what birds had to go from one density of medium to another density of medium. And he realized that the kingfisher, which you see on the right there, had to do this. And it's very important to the kingfisher's survival strategy. They may have to dive for food to feed their young up to 350 times a day. And if they generated a huge pressure wave as they dove from the air into the water, it would scare all the fish away, right? So instead it has a form and a diving technique that allow it to enter the water, as you can see there, with not even a ripple. And so he applied the idea of the kingfisher's beak and the shape of the kingfisher's beak to the front of the train, formerly the bullet train. And not only did he get rid of the sonic boom, but the train is also 15% more efficient. And he had such success with that first design that he actually looked to nature for inspiration to solve his next challenge, which was there's something on the top of the train called a pantograph, and it's an apparatus that it uses to capture the electricity, bring it to the train, and move it along. And that also made a lot of noise when it was traveling at high speeds. So again, since he was an amateur birder, he looked to birds for inspiration, and he looked at owls because he realized that owls have to fly, or owls are very silent in flight. Even if they're moving at high speeds, mice and other rodents don't hear them coming. So what he realized looking at owl feathers was that instead of having large barbules, or large barbs coming off their feathers, they have a series of very small ones, and you can sort of see that in that picture there in the lower left. And all of those little barbules coming off the larger barbs generate lots and lots of small vortices of air instead of large vortices of air. And he applied that same strategy to this pantograph apparatus on top of the train, and also got rid of the noise that way. So he works for a company called JR. This guy on the right is Dr. Frank Fish. He's a professor of biology at Westchester University, and he's been working on humpback whale-inspired strategy for over 20 years. And he had a really interesting source of inspiration, and that's something that will become clear throughout my lecture and throughout the course of the week. Biomimicry is really interdisciplinary. You can't just have an engineer succeeding in biomimicry. You can't just have a biologist doing biomimicry. You can't just have an architect doing biomimicry. It's very interdisciplinary, and everyone plays a role. And in Frank Fish's case, the person that was very critical to his inspiration was actually an artist. So decades ago, he walked into a gift shop in the United States, and he saw a sculpture of a humpback whale. And he noticed how the tubercles, or those bumps on its front flipper, were distributed. And he's a marine biologist, and he thought, that's not right. Why would those bumps be on the front flipper? That's not aerodynamic. But then, in fact, he went and looked at a real humpback whale and realized, well, that's exactly how they look. Why would that be? And so, he got some whale flippers from deceased whales, and he started to do a biological analysis of it. And in fact, what he realized is that those tubercles are very important to the whale's efficiency. So when the humpback whales feed, they use something called a bubble net. And what they can do is they can turn in very tight circles. These are huge animals, maybe, I don't know the metric, maybe 80 feet in length, very, very large animals. But they can turn and generate a lot of bubbles in just a 5-foot radius, so about the span of my arms. And they turn in a very tight circle, generate a lot of bubbles, and they capture krill in those bubbles, and then they can feed on them. But if it didn't have these tubercles or these bumps on its flippers, it wouldn't be able to make such tight turns because it would essentially stall out, just as an airplane will stall out if it tips too far to the left or the right. And so those tubercles make it more efficient and also delay stall. And he's been studying this technology, or he's been studying whales as well as working with engineers on studying the computational fluid dynamics of this. And I think about sometime in the last decade, he collaborated with a Canadian gentleman to form a company called Whale Power. And they're looking at applying this technology to applying this strategy to a range of technologies, including wind turbine blades and interior ceiling fans. And again, just as in the whale, in the wind turbines and in the ceiling fans, they're more efficient, and in wind turbines, they don't stall out at low wind speeds as regular turbines might. So I told you about sharks and being composed of their 2 polymers and how we use 350 polymers. And Novomer is an example of a company that's finding a new way to work with polymers. And so almost any green plant on the planet builds its structure out of carbon dioxide that it takes from the air, and it uses solar energy to convert that carbon dioxide to the carbon molecules it needs as its building blocks. And what we tend to do is we tend to take petroleum, in a very chemical-intensive process. We tend to break the molecules in the petroleum chains down into small parts, and then we take those smaller molecules and build them back up into the plastics and other molecules that we need. Polycarbonate plastics are the hard plastics that you see there. So Jeffrey Coates, a scientist at Cornell University in the United States, has figured out how to take an enzyme found in citrus peels and combine that with carbon dioxide and drive a cyclic process, just as happens in the plants, to form complex carbohydrates and polycarbonate plastics that are made out of carbon dioxide. So that's another strategy of nature. Nature uses really simple, abundant, common building blocks to build all of its materials. So right now we think of carbon as a very big problem in the atmosphere, right? And yet every plant on Earth is taking advantage of that very simple common building block, that carbon dioxide, to make complex structures. And now scientists are also beginning to learn from nature, how can we utilize the power of the sun? How can we utilize abundant resources here on Earth, such as carbon dioxide, and design better products from them? Regen Energy is a company out of Canada that's developed a product based on swarm technology. And there you see a flock of birds, schools of fish, honeybees do it. And you never see a flock of birds suddenly like crash into each other, right? So they use a few very simple rules to communicate with each other, and that allows them, to fly in a swarm or fly in a flock. And so Regen Energy has a device that it designed based on some very simple rules that allows electrical devices in a building to communicate with each other. And the idea behind this device is to reduce the amount of energy that's drawn during peak load. So peak load, at the hottest times of the day, when everybody's in their office or everybody's using their appliances, we tend to draw a lot more energy, and almost all of that energy, at least in North America, comes from coal and natural gas. So when there's a lot of demand on the energy system, most of that energy is coming from burning coal and natural gas. So what this device does is it allows all of those devices to communicate with each other so that they can still maintain their function. So for example, your refrigerator's never going to drop to a temperature where your food's going to spoil, but your refrigerator might not be running at the same time as your dishwasher, as your air conditioner, as your washing machine. So these devices actually communicate with each other based on this swarm logic algorithm to reduce peak energy loads by 20 to 30%. This is another process example out of the United States. Dr. Brent Constance is a professor at Stanford University, but he's also a serial entrepreneur. And several years ago, he wrote a 12-line email to a venture capitalist in the United States and essentially said, I have a better way to produce cement. Cement's a very energy-intensive production process. We have to mine limestone and heat it to very high temperatures in order to make cement. And we also release a lot of carbon dioxide, as we're heating the limestone to get the base materials we need. Why not manufacture cement like corals? Corals take calcium carbonate out of seawater at ambient temperatures and produce hard, bony skeletons, essentially like a marine cement. And so what Brent Constance and his company, Calera, have done is they figured out a way to mimic that process. And one of the strategies, they have a few different strategies for how they actually produce the cement. But one strategy is to bubble seawater through flue stacks from power plants and to extract calcium carbonate from that seawater as it's bubbled through the flue gas. And what's really amazing about this technology is that in traditional cement making, for every ton of cement that's produced, a ton of carbon dioxide is released into the air. And for every ton of cement that Calera produces, at least a half ton of cement is sequestered in the cement product. And actually, I talked to some of their scientists just a month or two ago, and actually in most cases, the amount of cement the amount of embodied energy that goes into manufacturing Calera cement is much, much, much lower than that. So that's a conservative number, the half ton of carbon that's sequestered for every ton of cement that produced, because they actually also save a lot of energy in their production methods. Manufacturing, again, at near ambient temperatures, just as the coral does in seawater. Cement's a ubiquitous product throughout the world. We're not going to stop building with it anytime soon. It's responsible for up to 8% of the carbon emissions globally. So what if we can sequester carbon as we're manufacturing cement instead of releasing a ton of carbon for every ton of cement we produce? Could have a huge impact on our carbon load. Biopower Systems is a company out of Australia, and they've drawn most of their inspiration from the marine world. And they have quite a few technologies that they have pilot projects running on, including, let's see, I think the one on the left is called BioStream. And so just as fish capture energy from vortices in the water as they swim, that fin-like device that's set in the ocean floor can also capture wave energy or tidal energy as it moves back and forth. And it can capture the energy in any direction. Just as a fish can change its direction based on where the tides are coming from, where the force is coming from, this device as well can work in any direction. So it's not fixed. It's adaptable to changing conditions in the ocean. They also have an energy capture system called BioWave, which is there in the middle. And this is based on how sea plants move in the waves, another energy capture device. Those look really small right there, but these are actually quite huge. I think they're set maybe like 80 to 100 feet down in the seafloor and might be, well, actually I think they're possibly that tall, but they're set quite far down. So they look very small there, but they're actually quite large energy capture devices. Biopower Systems has great video on their website. I definitely invite you all to check it out and see in video fashion how these technologies work. The final technology that they have is based on how sea kelp are anchored to the floor. And you can see that, you can see on the top right, that's kelp. And instead of having just one hold fast to keep it anchored to the floor, that kind of system has no redundancy, right? If you just had one point of contact to the seafloor, if anything happened to that one point of contact, you would lose the whole system. But in this case, they've actually created a holdfast for their energy capture technologies based on the kelp that has multiple points of contact with the ocean floor, so that the risk of damage is spread over all of those. There was one more thing I was going to say about that, but I forgot. Another scientist from the US, an ecologist out of the University of Vermont, is John Todd. And he has an invention called living machines. And in this case, it's a combination of bioutilization, or actually using biological organisms to do his function, but also biomimicry, because he has the components arranged in such a way that they emulate the organisms that are found in natural wetlands. So wetlands are awesome filters, right? I mean, they can filter out sediments, they can filter out toxic elements, they can filter out gases and whatever comes their way. It might take some time, but wetlands are really great at cleaning water. And John Todd's living systems uses a series of, as I said, of live organisms, so bacteria, algae, fish, aquatic plants, in a system that emulates the way a wetland system functions to clean water. And he has pilot living machines throughout the world. I think he has a couple thousand pilot projects going, including at Oberlin University in the United States. The largest one of these systems that's running so far is in Australia, and it's set up at a food processing plant. And the system can treat up to 100,000 gallons of water a day, which is the equivalent of what people in a town of about 2,000 people would use in a day. So imagine if every neighborhood of 2,000 people, instead of having to send your waste to a sewage treatment facility, or worse, directly into a river or stream, what if you had a living machine that could treat your wastewater right on site? And it's treated to a standard where that you can use it, really you can use it as drinking water, again, but most governments don't allow that under regulations, but you certainly can use it in a gray water system. The final case study I'll talk about right now is Interface Floor. And this company as well has been looking at biomimicry as a source of inspiration for, I think, over 15 years. And that gentleman on the lower right is a carpet designer. His name is David Oakey, and he's also on our board at the Biomimicry Institute. And about 15 or 20 years ago, Ray Anderson, the CEO of this company, Interface, realized that someday his company was going to be out of luck. That they produced a product that used petroleum. It was very energy intensive. There were a lot of toxic chemicals that went into their product. And he took a long-term approach. He had a long-term vision and realized that in the long term, his company wasn't going to survive if they didn't make some changes. I also just heard this story from another employee at Interface last week at our Biomimicry Education Summit, which I didn't know, but one of his early sources of inspiration for trying to do things in a different way was that a building in California, very early on, before there were any green building standards, any requirements to sort of build green, either for government or on universities or some places now that won't even allow you to build a building if you don't build green, said, we can't put your carpet in our building because it doesn't meet green standards. And so right there, he had lost a customer. So that was another piece that was inspiration to change. So in Interface's case, what they did is they put together, they truly put together an interdisciplinary team. They didn't just take all their executives into the boardroom and say, what are we going to do about this? Or they didn't take all of their designers and stick them in their design studios and say, you guys need to fix this, you need to come up with a better product. Rather, they brought everyone together. They brought in their designers, they brought in their executives, they brought in the business folks, they brought in their factory workers, people who actually worked on the floor, ran the equipment, were the ones who were responsible on a daily basis for making sure that things ran efficiently, that they worked well, that whatever system was put in place would continue to work for the long term. And at one biomimicry workshop that particular group participated in, they went out and they looked at, well, how would nature create a floor? And what they realized is that nature creates beauty out of chaos. So whether you're looking at a prairie or a forest floor or whatever covering there is in a healthy ecosystem, what you see is random colors and patterns that work well together. Like beauty arises out of the chaos. And so they took that strategy and they applied it to their carpet tiles. And so this saved them both a lot of money and a lot of time. So because of that strategy, so they use something called carpet tiles. Instead of generating one huge piece of carpet, they have individual tiles. And those tiles don't match. They have similar colors, similar patterns, but there's no exact way that they have to be laid down. So this saved their installers time because the carpet tiles could be laid in any direction. They didn't have to match at the corners. It saved customers in replacement costs. If there was damage or a spill on a certain section of carpet, you could just remove one tile and replace it with another. They didn't have to keep as much extra carpet in stock because if you had set colors or a set pattern, then you would have to match dye lots. Those colors would have to match exactly, and that's very hard to maintain in a manufacturing environment. In this case, they can have subtle variations in their colors, and when they replace a tile, it still looks nice. They also cut down on their hazardous waste disposal costs because they didn't have to manufacture as much carpet in order to get the product installed. Interface I also like them for a lot of reasons. I'll tell you a little bit more about them later on, but they've also been serial innovators in biomimicry. So they had such success with their carpet tiles. This line of carpet tile called Entropy now makes up 40% of their business. So pretty successful product. But they also were serial innovators, so they started looking at how how nature adheres or how nature would stick things together. Because traditionally, even these carpet tiles had to be coated with a toxic adhesive and stuck to some sort of backing on your floor. So they've now created something called tack tiles, which is a little device that just goes on the four corners where four carpet tiles meet. It just goes on the corner, because what they realized is that nature often uses gravity to hold things down. So they now use just a little bit of adhesive, and then gravity, as people are walking across the floor, actually keeps those tiles in place. So again, very much reduced their installation costs, reduced the amount of hazardous material they had to use, and reduced the amount of waste, and also made those materials much more ready for recycling. So those are the case studies I'm going to leave you with right now. I just want to expand a little bit on, I mentioned bioutilization and bioassistance, and I really want to make this point because biomimicry really is taking inspiration from nature. It's not using nature, and sometimes biomimicry can be done in combination with one of these other things. So when we talk about bioutilization, we're talking about consuming natural resources. If you go out and harvest wood to heat your home, that's bioutilization. You're consuming that natural resource. Bioassistance, for example, could be animal domestication or genetic engineering. You know, when we milk a cow or shear a sheep, we're using a product that an animal provides for us, but we're not consuming that animal. It still survives, but we're also not taking inspiration from that animal. We're just using a product it provides. Biomorphism I mentioned before. That's a superficial resemblance to something in nature, like the bird's nest building in China. There's no function built into that design. It simply looks a little bit like a bird's nest. And you'll often hear people talk about bio-inspired design. And at the Biomimicry Institute, we make a distinction between bio-inspired design and biomimicry. So bio-inspired design could be creating anything using inspiration from nature. It could be creating defense technology, like weapons. It could be, it could be creating robots just for the sake of creating robots, not because they serve any particular need. It could be creating technologies for space. So not necessarily products that will help us survive and thrive and live sustainably on this planet. So in our case, when we talk about biomimicry, it is innovation inspired by nature, but it's also addressing sustainability and human well-being challenge. So in that, I don't know if you can see that circle, but biomimicry is in that green circle set within the blue circle. So it's sort of a subset of bio-inspired design is one way to look at it. And I'll talk in just a minute a little bit about how we've been approaching biomimicry lately from these three areas of reconnect, ethos, and emulate. Something that helps us do biomimicry and teach biomimicry rather than bio-inspired design is a tool called Life's Principles. And we'll talk about these in more detail if you're participating in the workshop. But these are essentially design lessons from life. So these are things that nature does that can be observed in the biological world that help it be sustainable, that can be applied to human design. So I know it's hard to read that circle, but if you look on the outside, things like life-friendly chemistry, being locally attuned and responsive, so paying attention to what's needed in a local environment, integrating development with growth, optimizing rather than maximizing. So we'll certainly talk about those in a little more detail, but those design lessons that are drawn from biology help us evaluate our technologies to make sure we're getting towards biomimicry and not just bio-inspired design. So Life's Principles play a vital role in each of these three areas. For someone who's new to biomimicry, Life's Principles can be the link or the entry point into exploring another one of these realms. Let's see, whoops. So in Reconnect, there are some people that approach biomimicry or come to biomimicry because they have a passion for the natural world. So they might already be connected to nature, or they might be brought to reconnect with nature, as I think some of you will be this week. forcing you to be out there in the rain and out there, fully participating in the ecosystems that we're in. So some people come to biomimicry first through their love of nature. Others come to it from an ethos perspective. So folks who are interested in sustainability and realize that by looking to nature for inspiration, that we can create more sustainable innovations. Some people approach it from that lens. And then there are others who are purely interested in it for innovation. They realize that we have challenges that we haven't been able to solve. The best engineers on the planet, the best materials scientists, haven't necessarily been able to innovate that the way nature has over 3.8 billion years of evolution. So some come to nature knowing that there are innovation lessons there. And when we teach biomimicry, when we do our biomimicry work, we try to make sure that all of our clients or all of our students are aware of all three realms or all three aspects of this. And then life's principles is the overlay to all of those. It's a way to evaluate what we're doing. This is just a kid connecting with nature, probably not reconnecting with nature. As we reconnect with nature, it becomes more instinctual for us to look to the natural world for inspiration. This is a very, very important piece to all of the work we do. You can't just go to the books, you can't just go to the literature, but actually getting out, observing nature, participating in nature, sort of opening your mind to the possibilities that nature can provide solutions is really helpful in doing biomimicry. Oh, this was from a workshop here in Veracruz a couple years ago. From the sustainability perspective, these folks who manufactured this water bottle, and I know it's a water bottle, and I'll talk more about that in the second half of my presentation, but they were looking for a way to lightweight their product. And they looked to white bark pines and the way that they distribute material to be strong yet lightweight, and they emulated that in their water bottle design. So there's a spiral design to that water bottle that allowed them to reduce the amount of material that goes into that bottle. So yes, it's still a water bottle, but water bottles aren't going away anytime soon, and this is the lightest PET bottle on the market. So they were approaching it from a sustainability perspective, wanting to find a way to put less material into their product. And then I just talked a lot about interface floor, but why I think they're unique in terms of emulation and innovation is that they've gone beyond just looking at individual products to looking at their whole company. And can their whole company be inspired by the natural world? And they have a goal called Mission Zero. And the deadline for the goal is 2020, so not too far away. I think they're a little bit terrified about trying to achieve it, but Mission Zero, it's simply that they want to have zero footprint on the earth by 2020. So their CEO, Dan Hendricks, says, Mission Zero also unites the interface companies in our commitment to consider the environmental impact of every creative, manufacturing, and building decision we make. So it's not just something that's happening on the factory floor, it's not just happening in executive suites, or it's not just happening in the design studio, but they want every employee in their company to know what their mission is and to know what they're working towards. So again, Erin Mizan, one of their employees who I just heard speak last week, said if you go up to anyone in a warehouse or on the manufacturing floor of any interface facility anywhere in the world, because they're a global company, and you walk up to somebody operating a forklift and say, what do you do? He won't say, well, I drive a forklift and move carpet around. He'll say, I'm saving the planet. Like it's imbued throughout their whole culture. And that's the level of emulation we really want to see everyone get to, that we want to see you in your future careers practicing sustainable design. We want to see you emulate to that level. How do we leave no footprint on the planet? Yeah, I think that's very hard to read. But in that lower left corner, the little blue, I'm probably going to point this in my eye, I'm sure. This one? Yes. So in this corner right down here is something called operating conditions. And so operating conditions are just conditions on the Earth that affect all of these design lessons from life, or these life's principles. So some of the reason behind why life works the way it does or operates the way it does is because of these operating conditions. And they'll become a little more clear as I go through them. So one of those is that the Earth is water-based. And life has really learned to leverage that. Our bodies, our cells in our bodies are made up of 65 to 70% water. Water is critical to every living thing on the planet, and so it's really amazing the way we treat it, right? I mean, we are water-based, and yet we really don't give too much concern to what we put into our water, how we pollute our water, how we, waste or don't waste water. Earth also runs on sunlight. Most organisms on the planet get all of their energy from the sun. We're the lone species using petrochemicals. Earth is subject to gravity. Earth is subject to cyclic processes, lots of cyclic processes, but just one example here, tides. So how does Earth leverage that? There are always cyclic processes, sunlight, seasons, tides. How does nature leverage that? That's important to how life has evolved. Also, Earth is subject to limits and boundaries. So that little blue sphere on the left represents all the volume of water on the Earth, all the water on the Earth relative to the volume of the Earth. So when you see that little blue sphere in relation to the whole Earth, it doesn't look like very much. And that's all the fresh water, all the seawater, all the water in rivers, ponds, streams, everything that's locked up in polar ice caps. And so there's only a fraction of that is water that we can use. Less than 1% of that water can we actually use. So subject to limits and boundaries, that's all the water we have to play with. So, and this pink sphere on the right represents the volume of the atmosphere of the Earth. So again, we're doing a pretty good job of polluting our atmosphere, which is essential to our survival. That's all we've got to work with, so subject to limits and boundaries. And then Earth is in a state of dynamic non-equilibrium. That's kind of a fancy way for just saying that conditions on Earth are always changing. And with many of our technologies today, we try to develop products, or especially at the infrastructure level, things that will resist change, right? Resist earthquakes, resist tsunamis, resist high snowpack, high wind, hurricanes. We try to create things that will resist all of these changing forces. And most organisms on the planet instead adapt to those changing conditions. They've evolved to adapt to those changing conditions. They can withstand floods. They can, not always, but they can often withstand floods. They can withstand earthquakes. They'll survive a winter where there's 40 meters of snowfall. Like something crazy, right? The plants beneath that snowfall will still survive. So we try to develop technologies that sort of hold still, and nature develops solutions that can adapt and change and sort of go with the flow. So why is this all important? This is all we've got, right? This is our beautiful planet shot from space when this picture first came out back in the 60s. It was our first realization that, this is planet Earth. This is our home habitat, our home ecosystem. It's a beautiful photo. Let's protect it and survive for the long term. One other life's principle I just want to point out right now in the center, that actually says life creates conditions to life, creates conditions conducive to life, creates conditions conducive to life. It's in a loop on purpose. And that's really what organisms and systems do here on Earth. If your innovations, if your designs, if your processes, if they're creating conditions that are conducive to all life, then enough time, But there are lots of intractable problems that we really haven't been able to solve, and yet a healthy ecosystem without any top-down direction does create conditions conducive to life, and it doesn't do it by using clever human strategies. So quiet your cleverness, especially as you go out into the natural world, and just be open to learning from nature's experience. Take some time, go without your cell phones, go without your computers, just go out and begin that reconnection process with the natural world. I really think biomimicry is a hopeful solution for the future. So look at the world through a new lens. We're a very, very young species on this planet. We've only been around for a couple 100,000 years. So life has been evolving for 3.8 billion years. We've been evolving for a couple 100,000 years. So relative to the whole span of life, we're very young. We've made some mistakes, right? I'm going to take Raul's comment here, but if you compressed all of the geological timeline into 1 year, I think life would have come into being back in March. So if you take the whole history of the Earth and compress it into 1 year, life arose in March sometime. Humans came into being, is it 6 minutes? 6 minutes, I forget. 6 minutes before midnight on December 31st. So relative to how long life has been around since March, we've only been around for 6 minutes in December. And the Industrial Revolution has been basically like the last second of the year. So Raul has said, just imagine what we can do in the next second. So please come and join us. I'll tell you more about what we do and how you can join us, but we really invite all of you to come and play in the biomimicry space. It's a great place to be. And always remember to get outside. And that's one of my, that's my pooch, and he's one of my sources of inspiration because he gets me outside in all kinds of weather and every day throughout the year pretty much. So he's a good reminder for me to get outside and observe. So, thank you.
Questions and answers. Preguntas que tengan con respecto a esto que nos ha presentado Megan.
The thing I might mention is because it's so ubiquitous in our world, we might forget that it's there, but the internet is a giant social experiment, and it's also based on some concepts like swarm technology, or excuse me, just the concept of the swarm, concept of networking, concept of putting information just in time in different places without a top-down hierarchical structure. So all the spin-offs from the internet are examples of social, maybe it's informal and maybe it's, how you say, non-hierarchical social engineering, if you will. It's not really being done consciously, perhaps, but it is shaping our social societies and our cultures. And a lot of the initial and basic concepts of the internet are based on so-called eusocial insect societies, the bees, the ants, and so on and so forth, where they're basically algorithm-driven behavior in these animals. They have a certain set of inherited behavior, but they also have linked with that a set of behaviors for the immediate environment, what the ant next to you is doing, and so on and so forth. So I know E.O. Wilson, who wrote the book Superorganism, talks a lot about these eusocial insect societies, and it's a linking of those two kind of forms of behavior that allows these societies to do what they can do. Megan showed that image of the termite mound. Well, relative to the size of the builder, that's the largest built structure in our planet. There are these huge compass mounds and so forth, but they're able to do these very complex things with those teeny tiny brains, and it's because of those concepts of innate behavior and also adaptive behavior. So those are animal concepts that drove a lot of the algorithm-driven internet development. Also now you see in architecture parametric modeling, which is the same thing. It's algorithm-driven and so forth. So there's a lot of lessons to be learned still from that arena.
So just to put that in context for some of you, so in terms of life's principle, the computers are built on simple common building blocks. So what Tom is talking about with these simple rules is that everything that you see on your internet, on your electronic display, whatever you can do on a computer, from the simplest text message to the most complex graphics, is possible because of a system of zeros and ones. The language of computers is based on zeros, on two numbers, 0 and 1. That's it. So the way everything is arranged. So that's an example of organization based on simple common building blocks. This isn't quite what you were getting at, I don't think, but industrial symbiosis is another example. So not an individual company, but can your organizations find other organizations to interact with to form a system? So that's another way. I'm going to talk about one of those examples in the second half, but that's another level in which you can think of how can you apply nature-inspired design to your organization is what makes a system function well, and how can your organization function within, what is its system, how can it function, what's missing from the system to make it healthy, what's redundant, how can you collaborate within a system, so.
Well,
There's one
maybe-
question.
Just redondeando la pregunta que hiciste. Aquí todavía no se entra al detalle de todos los life principles. Pero uno de ellos es que la naturaleza, la vida, funciona, todos sus diseños son multifuncionales y que no maximiza sino optimiza. Con esos dos principios, nosotros llevándolos al diseño urbano, vamos a identificar muchas soluciones. Y the other example, which is very interesting, is Apple, how Apple has evolved their products, Mac. So.
I have another question. I believe that there are very good examples that have been, like as she was saying, industrial design. But I don't know if it's, my question is exactly, why hasn't there been more of these? I mean, if a termite mound is a very good example of controlling energy, and then you have this mall in Tanzania or somewhere, why isn't there like replicable projects like this? I mean, why isn't it like the next revolution, or I don't know?
Well, I think that's a good question too, and I think it's a very young discipline. So hardly anyone was thinking about this at all before Janine wrote her book back in 1997. And really, she wasn't promoting biomimicry as a discipline per se back then. All of the people that she profiles in her book were what she calls bench scientists. They were scientists, hidden away in their labs or their research plots because they loved biology or because they loved ecology, and they happened to see a possibility for applying their research to human challenges. But it really started, sort of as scientists were doing this work, and they weren't bringing architects or industrial designers or business folks into the process, and I think they're still struggling with it. Frank Fish, who developed the tubercle technology and the whale power company, he's struggled for 2 decades with the business end of it. So he is a biologist, he knew how to get some engineers involved, but then all of a sudden it's like he's formed a company, and he faces the same challenges as any new business. So now he's not only learning the biology, learning about the engineering, learning how to work with designers, but now it's also like, well, how do I market this product? I know Calera Corporation, Brent Constance in the United States, he runs up against subsidies from the US government. So, you know, green manufacture of cement is not subsidized in the United States, but nuclear power is. You know, so certainly at some scales, government plays a role. I think another reason that it's not more replicable is we don't require any of you who aren't biologists or ecologists to take biology, right? So biology, learning biology from a functional perspective, which none of us do, is a good. It's not the only key to doing biomimicry, but it's a good starting point for understanding how to talk to other disciplines. So if you can think about what you want your design to do, how you want it to function, rather than what you want to design, then it allows you to go and talk to an engineer or look to the biological literature. What do you want your design to do? How does the biological world do that function, right? But we don't teach biology from a functional perspective. We tend to teach biology by throwing out a lot of facts you have to memorize about maybe how tall something grows or its life cycle or you know, complex chemical formulas. So I think that's another reason is that we're not promoting biology, learning biology, both for those not in the biological disciplines nor for those actually studying biology to use it in a way that they could apply it to designs. Those are a few reasons. There are some Mexican companies practicing biomimicry. Do you want to talk about those? I'm familiar with just a couple.
Bueno, hay algo que hemos hecho nosotros en el despacho, que lo compartiré al rato. I don't know any other.
Than yours?
Real, to talk about them. I know a lot of people has been working in this, but not the examples,
And Toa has
not the
it.
cases. Toa. Lo que es, yo creo que mucha inspiración de la naturaleza hemos utilizado a lo largo de la historia de la arquitectura mexicana. Con la metodología y los procesos de diseño que surgen del biomimesis, de biomimicry, pues es muy poco, porque pues nosotros iniciamos biomimicry en México, lo trajimos hace 5 años, 4 años. Entonces, pues obviamente pues es nuevísimo, entonces somos muy pocos los que estamos empezando a trabajar y ya de por sí hacer diseño ecológico de manera convencional es un reto, hacerlo con biomimicry es un mayor reto. Y también, bueno, pues el uso o el trabajo en colaboración como diseñadores del biólogo, pues también es otro factor importantísimo. Y mientras haya 2 o 3 biólogos ahorita en México que estén manejando y conociendo bien esta disciplina, pues no da para más. Entonces estamos en una parte formativa todavía.
We're trying to very quickly scale up the interest in biomimicry. Education is part of it too. I mean, all of you are professionals, but no one was studying biomimicry when they were a kid, right? And we have programs that start at that level too. And I think as children begin to learn about biomimicry at an earlier age, we definitely see college students now demanding it. They ask, where can I go to study biomimicry? I think the number of people practicing it will rapidly increase.
Biomimicry includes not only the design, sorry. Does biomimicry just only include the design of the building, of the product, or whatever, or it include either other kind of activities like the design and implementation of compensation programs, conservation programs, to make that I don't know, if we're talking about, for example, for a tourist project, no? To make these programs to conserve wetlands and turtles and all the conservation areas, to make that all the concept of the project get involved in the nature and and achieve a better friendly environment performance.
And that's what ultimately we would like to see, is biomimicry at the systems level. So I showed you a lot of individual, emulating the form of something just in one product, or emulating a process, and maybe getting a little bit to the system level. But I think if you're emulating nature at the systems level, then you would be taking those things into account. And again, Life's Principles is a tool that can help you do that. I mean, in that center, if your project or your company is creating conditions conducive to life, to all of life, then conservation would have to be inherent in your policies. And creating conditions conducive to life would also mean for your employees, right? Are you paying a living wage? Are you providing health care? And those are very challenging things to do, we understand. But that's what Interface, I think in some ways, is trying to do. They're trying to look at it as their whole system. How can they integrate sustainable design and biomimicry into their entire company? So.
There is a company in Cambridge, Massachusetts that I'm assuming your question is about, can you take biomimicry or bio-inspired principles to the organizational level and solve a problem in that way? One example, and sort of ties to the previous question about insect societies and so forth. There's a think tank company in Cambridge, Massachusetts that runs algorithms in order to solve organizational problems. And one of the examples that they use is there was an oil rig repair company in Texas, and they had various crews that they would get. They would get people from various places in Texas, put them together as crews, and then send the crews out to get materials. And then they got their materials, then they'd have to go to some sort of rig site out in the middle of nowhere. And so they have this scheduling, this very complex scheduling problem or challenge. And so some workers would be off that day, some wouldn't. How do you get all these things together? And so they actually studied how ants or other insects might, what's the most efficient pathways that these ants might carry food back to the nest, or so on and so forth. So based on that inspiration, they came up with an algorithm for this company, and surprisingly, the routes that these trucks or these rig repair vehicles would take wouldn't be the most direct routes that you might think. But overall, within that network, it was the most efficient thing for them to do, to both get the materials, save the most gas, get the people where they were needed at the right time. So that's an example on the organizational systems level of nature-inspired solution. Thank you.
I have another question. I have the microphone. How much is the Biomimicry Institute mimicking like indigenous traditions or beliefs or like technologies, if you would say?
Well, I would say our take on that is that indigenous peoples emulated the natural world around them. They took inspiration from observing plants and animals and ecosystems that they lived in. And so we do not actually look at emulating indigenous strategies, but rather we have worked in communities where we've gone back and tried to look at what was going on in their ecosystem or in their habitat, and how that might have applied to how their ethos or their designs arrived. So in this past year, my colleague, we also have a consulting branch, and my colleague on our consulting arm was working on an architectural project in Nevada, and there's an American Indian reservation in the area. And so the architectural firm was very concerned about not offending, you know, the American Indians, the native peoples there, with whatever they designed. And so what they did is they used life's principles. They did a design charrette based on life's principles, and they brought in tribal members, and they got their perspective, but they did it through this lens of life's principles, through looking to the natural world. And then, of course, their perspective, you know, came into play out of how their culture had developed. But it was all from the framework, from the lens of what inspiration did they originally take from the natural world. Does that make sense? That was a little.
I believe that they have been doing a lot of things, like the milpa, the aspects that they would have like multiple plants that would, you know, like, I don't know if they did it because they were very smart or they really saw nature, how it worked, but, you know, Delphine was telling us about, you know, like, certain plants like the beans would give in nitrogen to the corn and stuff like that. Mm-hmm. So in a way, they know a lot of things, and it's been lost. So if the Biomimicry Institute would, you know, like, come down to the indigenous, really see what they have learned, then you could jumpstart a lot of things that they have really seen. And maybe it's important that you would, you know, like, really make an investigation not only on looking into nature, but looking on people that have really found things on nature and then exploit that in a positive way, you know?
No, and I mean, local context is very important. I mean, some of these designs, it didn't matter as much as others, but especially when you're designing some of the work that our sister company does, or, you know, that you would do on the architectural side or the site planning, site development side. We look at something called the genius of place. So not just looking at how any organisms solve a challenge, but how do organisms in that place solve a challenge. And that's a situation where certainly bringing in indigenous knowledge would be highly relevant, but again, for us, it's about looking at it from a perspective of lessons learned from the natural world, and if those native peoples can share observations or perspectives on the natural world, so much the better. But I think in that case it's very site specific. So in the case of our project in Nevada, because there was an American Indian tribe there, it certainly made sense to bring them in, but we're not specifically looking to go and work in areas where there are native populations. But I think anytime that we have or that we will, certainly we would want to bring that perspective in. I mean, they would be one of the stakeholders in the project. And I just want to say it's also, you know, it's also not up to us. Like, we're not experts. I mean, Montana's not my home. I grew up in Wisconsin. I'm a transplant. I've been there for 10 years. You know, I now consider it my home habitat, right? But 10 years of experience in a place isn't like hundreds of years of a tribe passing down knowledge, right? So I think it's up to, you know, all of you or everyone else who is trying to practice sustainable design to also consult, you know, native peoples in whatever communities you're working in. So I don't think it's necessarily for us to go out and try to capture all of that knowledge, but rather whoever is working in places where indigenous knowledge could play an important role, it's important to engage them in the process.
Sorry, about the consultant, how it works. Like, if I have a project like an architect, when I find a problem, I go to you and ask for a specific solution, or since the beginning we start to work together?
Yes, so our consulting practice has, Janine and Dana founded our consulting practice back in 1998, and it's continually evolved because it's a new practice, right? So we're constantly learning lessons about how best to proceed. And we've really found that we want we want to work strategically, so we don't tend to work on small projects with individual architects. There are other people that are now trained, you know, who can do that work. But we do have a strategic partnership with HOK, if you're familiar with them, a global architecture firm. And so we're really trying to, because it's very hard to build biomimicry into the project or the billing. So because we have this strategic partnership with HOK, we can come in as a contractor, essentially, with HOK on any project they bid on where they think biomimicry might be feasible or the client might be open to biomimicry. Then we can come in at the proposal stage and pitch the biomimicry aspects of the project as they're pitching the overall project. But it's certainly, we've found that it works much, much better if we're in at the very beginning. If somebody brings us in very late in the project and you're just trying to sneak biomimicry and slip biomimicry in somewhere, it doesn't work very well. So, did that answer your question? I am. Oh.
How do you see it?